Hi, my name is Mark Collins. I'm a Director of Remote and Autonomous Systems here at SMD. We've had a lot of questions about SMD's new EV robotics range, and we're going to be answering a lot of these questions in a series of videos that we're going to be releasing on Facebook and LinkedIn over the coming weeks. So let's start with performance. There's been a number of electric vehicles in the market. Generally these vehicles have been a lot smaller, but there have been some work-class vehicles that have been out there in the market the last couple of years. These vehicles, I would say, have been medium performance vehicles. What we have here is a very high performance work-class vehicle. When I say high performance, the thrust figures on this vehicle are around about 1,300 kilograms. That's way in excess of even the most powerful hydraulic vehicles currently on the market at this moment in time. The next thing that's slightly different about this vehicle is the DC voltage transmission system. It's 10% more efficient than an AC system, which is traditionally used with vehicles of this type. It acts like a bus bar, which means that you can actually hang different items off of the umbilical system, such as TMSs. The umbilical that you're using in a DC system requires less conductors, and it's 10% more efficient when you're transmitting the power from the surface down to the bottom. Having a DC system as well means that it's ready to accept battery technology as well. Straight plug and play onto the vehicle, as we see. Other things that are different, it's a fully modular design, so everything on the vehicle can be taken on and off in a matter of minutes. That includes the thrusters, the HPU that you see here, the power distribution system that's on the vehicle, the pod, all removable very, very quickly in a matter of minutes. The way in which we control the thrust system is quite unique also. We have combined the drive into the thruster motor. That means close proximity, means it's a very fast control loop. That control loop then sits onto an Ethernet backbone. That Ethernet backbone then allows for sensor fusion technologies and over-horizon technologies to be plugged in very quickly. The vehicle has a very advanced flight stability system. This uses adaptive PID modelling to actually anticipate what the vehicle is going to see when it moves within the current. This will give a very, very stable platform, and ultimately that is what we're trying to achieve with this vehicle. Stable platform for high quality data, high quality tooling operations. Hope you found that video interesting. If you have any questions, please get in touch. Details will be at the end of this video. Thanks very much.